Okay, welcome back to yet more functions. Now, functions might seem extremely difficult in the beginning with so many moving parts and this x value giving that y value and how to draw it in different ways. But the more you draw it and the more examples you do, and I'll attach let's say an example sheet or a worksheet to like by the end of the series, maybe in the description eventually, and then I'll obviously do those examples with you as well, but the practice makes permanent. That's kind of what I want to tell you, is don't lose heart, because you might look at this now and have no idea what it looks like or how it will look, but later when you see this, you'll be able to say, oh, okay, well, this is going to look something like this. And how do I know that? Because I know the -2 value, so that y-intercept would be below the x-axis. And I know this is 3/1, so it would rise a lot quicker than it's running. Whereas if I had something like this, y is 1/3 x plus 2, that would be a y-intercept above, and then that is a lower gradient, so it would be not as steep as this one, actually be opposite steepness. But if you can't see that right now, don't worry. But in today's video, I want to try and explain kind of just the basics behind input and output values when it comes to functions. So first of all, we're going to have to draw this function any way we want to. You can use any way you want to. I'm going to use let's say I'll do the just double intercept method. Okay, just because I like it. So let's say we had a question and they said, okay, let's just think about the question first. They say, okay, part 1 is draw the function, draw it graphically, and 2, determine the y, I'm going to see, can you still read there? Can determine the y value for coordinate with an x value of 3, and they can say do this graphically, So what this means is we can do it not graphically, and we'll look at that as well. But what they want us to do is they want us to draw this graph, and then from the graph we're going to have to determine the y value where the x value is 0. So somewhere we're going to look for the x value of 3 and then check where the y value would be, and then kind of indicate on our graph what that looks like. So let's quickly just draw this first. So I'm going to use the double intercept method. So for my y value, like for my let's say x-intercept, I know y would be 0, so I would do 0 is 3x minus 2, and that would be 2 is equal to 3x, and this would be x is 2/3. Okay, so if you didn't catch that, I just added 2 on both sides, and then I divided by 3 on both sides, so x would be 2/3. It's not very nice, because I'm going to struggle to find 2/3 on there, but it's not the most difficult thing. So my x value is 2/3, so it would be around there. Okay, and my y-intercept, I can just, because it's in standard form, I can just read it off, and that would be -2. So that would be there. Okay, if I wanted to use a different method, I can use the gradient as well to determine it. So for that one, I think I'm going to use that now just because it's a bit more accurate, because I got a fraction there. I want to work a bit more, let's say, accurately. So I can start with the -2, which we have here, and then that gradient, I know my gradient is 3/1, so it's 3 rise, run 1. So from here I have to 3 rise, which is 1, 2, 3, and run 1, which is there. So I'm going to draw my line. So I did catch that. There we go. So I had to draw this. And now because they asked us to, oh, no, it's rubbed off, but they want to find the y value where the x value is 3. There, I'm going to have to do it graphically, and I'm going to go with just going to draw it with this marker. X is 3, so I'm going to go with x is 3 all the way to there, and then from there I see, okay, my y would be 7. So in this case, I showed to them if x is 3, then y would be 7. Now, I didn't necessarily have to do it graphically, but they asked me to do it graphically. So what does it mean? So the thing you'll have to understand about these functions is, because it's a straight line, every x value would have one y value, and they kind of, they come in pairs. They work in pairs together. So if I looked at this, for example, if I said my y value is -9, my x value would be somewhere about like -2 1/3. They kind of correlate to one another. So I could actually, if I use this, y is 3x minus 2, and they didn't ask it graphically, and they just wanted the y value where the x value is 3, then I could have just said y. Let's just input an x value of 3 here and take 2 off. And then we see y is 9 minus 2, and that's 7. And that's exactly what we got, is 7. So what you need to understand about straight lines is there's kind of input and output values. So if I give an x value on this line, then I'd get a y value. And then it would kind of, this equation would always be true. Let's draw on this one, we'll draw another example, and we'll find something else graphically. Let's say, we'll do one more example. Maybe on the, okay, let's go, I just thought of something. Let's do something like y is equal to -2 plus 2. Well, not -2 plus 2. Let's do -2x plus 1. Okay, so I'm going to use the, let's say the gradient method with this one. So I know my gradient, or my y-intercept here would be +1. So that's right there, +1. And then the gradient in this case would be -2 over 1. So this would be the change in y over change in x. So it means I have to drop 2 and run 1. So if I started here and I dropped 2, 1, 2, and I ran 1, that's over there. Or I can do the opposite. I can rise 2 and run -1. So I could do 1, 2 up, but then 1 back. And I'll quickly draw this line. Okay, so let's say they asked us to draw this new line. I'll just name the line. So this one was, this is y is equal to -2x plus 1, since we're busy with this one. And let's say they asked us, hey, graphically find out what is the value of, what's the y value, or what's the x value? What is the x value? What is the x value where y is equal to -9, for example? So what I have to do now is I have to look at my graph. I have to find -9, and I just draw a line towards my graph, and I find that point, and I go up, up, And then I see, okay, so it would be 5. X would be 5. So the coordinate there would be x is 5 and y is negative 9. Okay, now I'm not going to do this in this video. I'll do this a little bit later. We have 1 or 2 other things we can do before the time. But I have 2 lines here and they cross. And it's something very special where they cross. So I'm going to mention it now. And then later we can look at the detail. But just know something is up. And we're going to look at it a bit later. Where these 2 lines cross at that point, the x and y values would be the same. So if I were to look at this line and I gave the x value of whatever this is looks like it's, let's say, it won't be 2/3, but let's make it a half. Let's say that is a half. If I put x value of a half in here, then I'd get, let's say, a third out, but it's the same for this line. If I put x value of, let's say, a half in here, then I'd also get a third out. So it might not make sense right now, but just think about that for a second, that where these 2 lines cross, the x value or the rules for the x and y values would kind of be the same. So if I put the x input and I'd get the same y output for both lines at that point. But just know it. We'll look at a detailed example later.